I'm going to make this video very quick because I want to keep it very, very simple. So as you can see on the left, we've got the sun. Over here we've got the Earth and the Moon nice and close together. When you zoom into the Earth over here, so obviously 2,742 kilometers in diameter, I drew in the tiniest of all scales. The computer is grinding just trying to get down to the man. So this little tiny line, that is the height of one man, so it should be 2 meters. So I can't really measure it because it's just too small to be able to show up, but it says 0.02, so that's basically 2 meters. For every unit is 1 kilometer. Now this green and this light blue, the green is 0.2 of a degree rotation. This blue is 1 degree of rotation. This is the pink one here is 0.2 of a degree rotation, and this is another 1 degree rotation. So the yellow side is facing the moon, the blue side is facing the sun, and so from just before I get away from this, so this is 100 at 1 degree turn is 111 kilometers in distance. So for that very small distance there of 0.2 degrees turn, it's 22 kilometers in distance. So when we spread that out, the actual angle that this person can see at, and this is keeping in mind where it strikes a point, which is like everyone says, three-ish miles off the horizon. So that would be the point where you can't see below anymore if you are at sea level. That is sea level. If you're up on a mountain, you probably can get a much wider angle than what this is, but this is sea level, so 2 meters off sea level. So this person basically can see 179 degrees and 42 arc minutes, which basically means they can see beyond level on both sides, slightly down. So they can look slightly down to the left, look slightly down to the right, and they can see everything above them, obviously, as you can see. And so this is the moon over here. Just to clear it up, what I've done is I've put the penumbras and the umbras in boxes because there were just lines going everywhere, so I've tried to keep it cleaner. So when you're on the absolute top of the planet, when it's exactly the sunset time, is this red one, which is called top. This is the 0.2 degrees in negative and the plus. This is 1 degree in the negative, so that would be when it is facing the sun. The 1 degree plus would be when it's facing the moon, and 2 degrees is even more cranked to the moon. Now, one of the things I mentioned online was that you still get civil light for at least 6 degrees of the rotation of the Earth. So all the way, if 6 degrees was all the way down over here, it would still be glowing orange above your head as the sun has basically set. So the sun is set, everything's still glowing yellow, orange, and purple above your head, and you will see this moon exactly where it is. So yeah, so you could basically see the penumbra at 2 degrees. You can see the top penumbra at dead level, and visuals for being able to see the moon when it's pointing towards the sun start to disappear. So when you're at 1 degree, keeping in mind that I haven't allowed for any refraction around the horizon at all. This is just straight lines. So if you were 1 degree off facing the sun, the moons, if they were still in this location, would be pretty much hidden. But of course the moon does move this direction anyway, so it probably could climb up a little bit more, but ultimately once you're facing day, it will be gone. And to explain that in the other direction, well, it's quite far. It's very, very far. So if you're on the top of the planet, and you're dead square, right angles to the sun, your top can look down. When you're looking down and you see the horizon 3 miles off in the distance, you will see like a good 60% of the sun without too many issues. And if you are like further into the day, the -2 degrees over here, you'll see a lot more of the sun. When you're down to 1 degree, the sun's basically risen for you. You're basically seeing the sun above the horizon. It has risen. Now I think I estimated this 1 degree was about 8 minutes in time. So if this 1 degree here is 8 minutes, I'm assuming this 0.2 degrees is about 1.5-ish, 1.5 minutes. And so this is probably 1.5 minutes too. So basically, if the sun has risen, you can see half point. Another 1.5 minutes later, you'll be able to see the bottom of the sun as well. So that's what that is. And so this is 1 degree up here. So this is if you were on the backside of the planet, you would not be able to see the sun exactly. You would not be able to see it properly, except for that little bit of refraction that will come. And I believe that it was like half a degree anyway. So I wouldn't be surprised if you started seeing the head of the actual sun popping over at about that half a degree in rotation. So 30 arc minutes. So as you can see, this yellow that's on the top side is basically reflecting down this way. So that's down low, and of course the blue one, which is up high, is down low on that side. So that just shows that everything has basically rotated. It's all rotated correctly. To zoom in a little bit closer, what you'll see is as you can see, it's all quite small. Look, it's pretty darn flat at this rate, isn't it? How level it is from this point here to that point is quite small. And as you can see, the person in the blue, they can basically see down a little bit sharper. And if you're on the backside of the planet, you can still see up over here. But of course, that is the point where your eyes will be above the sun. So it doesn't take much. At this scale, you basically can see 180 degrees in two different directions. And when you think about the fact that the moon is all the way over here, it doesn't take much. It does not take much at all. Let me just think, while I have it here, what I might do is I might just find out how much the bottom penumbra actually is down below, because as you can see, it does show, well, yeah, I mean, obviously this, you can show it just here. So as you can see, that dimension there, I think it says 2 point, oh yeah, that's right. It was 2 degrees off what, because this top had already gone down this fraction here, this 837. So basically, because it's looking down, that's the 837. That's the 8 arc minutes down. So this 2 degrees is looking down, and it's also 2 degrees around the corner. So that's why it is. That's why this answer over here is 2 degrees and 8 arc minutes. So yeah, so dead straight, you should be able to see the moon. Looking at that white line right there, it goes dead straight through the top moon of the top penumbra. So dead level, you should be able to see it all. So that explains all that. So, and that's the true scale. You can see the distance. So the distance that we are away from the moon is so tight in comparison to the distance over to the sun. The sun is very, very far away, and scale always seems to bedazzle flat earthers. It does it every single time. And I made a meme tonight about it, and I might just post that here. So if you like what you've seen, if you want to see me do more of these types of experiments, obviously hit the like button, comment your requests or any comments that you have. If you think that I've done it all wrong, comment that too. I'd like to see what you actually think. And I'll just say, if the sun has come up in your area, subscribe. It's dumb, but I mean, I got to bribe you somehow, don't I? The sun comes up, subscribe. Stupid.